Okay, so what you already know about how to multiply two binomials together we did with the area model. So obviously, just as a reminder and as a connection to what we're going to talk about with the double distributive property, we're going to work this one out first with the area. So we'll start by basically doing the top rectangle. That's going to be 2x times x, which is 2x squared. And then you're going to get 10x when you do 2x times 5. Then for the green rectangle, you're going to get 3x, and you're going to get 15. So to get the total area, we would simply add up all of those smaller areas. But the goal of this part of the lesson is to go ahead and do this all with symbols, not with just the area method. So over here on the right-hand side where we have our multiplication problem, we're going to go ahead and we're going to see that what we need to do is do the height of the purple rectangle, which is 2x, and that's going to multiply by the width, which is x plus 5. So essentially what's happening is we are taking this 2x and essentially multiplying it by the binomial. And then we're going to do the exact same thing with the 3. That 3 is this height of the rectangle over here on the left, and so that's going to be plus 3 times x plus 5. So what we just did is essentially the distributive property that you have been doing all year. It's just that this time there's actually two distributions. So we're going to distribute the 2x, and then we're going to distribute the 3. So we'll go ahead and do that now. This is the second distribution. So 2x times x is 2x squared, and then you're going to have 2x times 5. So that's going to be 10x. And again, you can see that in the purple rectangle here. Okay, and then we're going to do the green rectangle, but this time all with symbols, so pretend you can't see that picture. So that would be 3 times x, and then 3 times 5. And so that is a second distribution. So second distribution. And then we're going to go from there and we're just going to combine our like terms. So as we do this, we're going to have 2x squared, and then we have 10x and 3x, that's going to be 13x, and then 15. So essentially we're doing all of the exact same math that you were doing when you were doing the area model. It's just that we're writing it all the way out in symbols. And I need to make sure that I'm really clear on one thing, which is that it's the process here that we care about. I don't care about the final answer there. And yes, it does seem like a lot of writing, but you need to write it all the way out completely. No ifs, ands, or buts. And the reason is that I want us to be so familiar with that process that we can work backwards through it. So that if I start you with that final answer, you can actually work yourself backwards. That's our big goal. So for right now, you're just multiplying those two together, and that's that. So let's look at the distributive property in more depth. So the distributive property you already know says that when you do 3x times x minus 6, that's really saying the height of the rectangle is 3x and the width is x minus 6. So that would require you to do distribution, which you've been doing all year, to get you 3x times x, 3x squared, minus 18x. And that's again simply 3x times x is 3x squared minus 18x. So that would be your expression, and that expression is exactly the same value. We'd say those are equivalent expressions. There are two ways of writing the exact same thing. They still have the same value. So the only difference for today is just simply to say that when you have a binomial times a binomial, that's going to be 3x times that whole thing. So again, 3x, and then the binomial means that it's x minus 6 wide. And then you're going to have the same thing. This 1 is going to multiply, but it's going to multiply with the whole thing, the whole term, or sorry, excuse me, the whole second binomial. So that would be 1 times x minus 6. And that's really all there is to it. So you simply write it out. 3x times x minus 6 plus 1 times x minus 6. And notice I'm not color coding here, but hopefully you're seeing each of those two terms. So that's the 3x, and that's the plus 1. And then you would just simply continue to distribute again, which are the little individual areas. So minus 18x plus 1x minus 6. And then condense your like terms, 3x squared minus 17x minus 6. So that's the double distributive property, which means that we've just done it twice, so that doesn't keep us from doing more advanced stuff like the triple distributive property. But I'm going to go ahead and leave that to you for the moment. I think you could probably figure out what to do with that. Basically, you're going to have, actually, excuse me, it's not triple distributive in this case. It's still just double distributive, because we're going to distribute this with this whole term, and then we're going to go ahead and do the same thing. We'll have our plus 3 times that trinomial. So if you were going to tackle that problem, it'd be x times x squared plus 2x plus 4, just the distributive property, plus 3 times x squared plus 2x plus 4. And then I would go ahead and distribute and then simplify, but I'm going to leave that problem undone for the moment. I'll let you finish it up.